All right, ladies. Section 3, I believe. Section 3, solving equations. We also need to know the difference between an expression and an equation. So expressions can be translated, verbal ones can be translated into algebraic expressions by using language of algebra. So minus, plus, subtracted, decreased, product, quotient, all of these things over here in this box. All of these things, okay, are language of algebra, okay? So we're going to write an algebraic expression to represent each verbal expression. So we have 2 more than 4 times the cube of a number. So we first want to start off with 4 times cube of a number. So we're going to look at this. Because 2 more means we're going to add on to it, right? So 4 times cube of a number. And I always use x. It's just easiest. If they specify a variable, you would use that. Plus 2, right? Because more means adding. And times, obviously, is multiplication. Cube is to the 3rd power. Next one. The quotient of 5 less than a number and 12. Okay, so that's a bit kind of wordy there. The quotient of 5 less than a number and 12. So really, if we were to rearrange this, it would be the quotient of a number and 12 less than 5, essentially. So 5 less than that quotient of a number and 12. So quotient means division, and 5 less than that quotient. So again, a better wording for that would be 5 less than a quotient of a number and 12. Again, I'm not going to try to trick you or anything like that, but that was a difficult one. 3 times the difference of a number and 8. So I need to start off with the difference of a number and 8. So what does that mean? The difference of a number and 8 is subtraction. We see up here difference in our box up there. Difference. And it says 3 times that. So that 3 times that difference. Okay? So those are just expressions. If I add in 3 times the difference of a number and 8 is, so if I were to add on, is or equals, it becomes equals, let's say 12, right? If I add this on, it becomes an equation. All right? And that's essentially what we're about to translate into words, would be these equations, right? A verbal sentence to represent each equation. So we need to use is or equals, okay? We need to use one of these words for an equation. So let's start with the first one. 6x. What can we say about that? We can say 6. Let's actually write out the word 6. 6 times a number is 72. So again, we're just adding on this last piece here. Okay, is something. So the difference between an expression and an equation is we add the equal sign, which we use the words is or equal to. Okay, let's try the next one. Oops. 6 minus 5 equals -2. I literally just said it out loud, what we could write down. We can use fancier terms. We can say 5 less than a number equals -2. Okay, and again, I'm not going to say that you have to use that. I like the differentiation there, right? I like when students mix it up. But you could say 6 minus 5 equals -2. I'm okay with that. Ooh, we got something a little bit more complicated. So let's start off with the 2C. Okay, so we have 2 times, or the product of a number and 2 times a number is the number n to the second power, or we would want to say the number squared minus minus 4. Again, we could also say, we can reverse it. We can say a number squared, or 4 less than a number squared, is the product of 2 and that number. Okay, so again, that is always matching up with an equal sign, and then we have the other stuff. All right, so again, it's the language of algebra. Now we're going to actually solve these, okay? So you had to do this in geometry, set up equations, and then solve them. So these are pretty basic. And yes, you can use your calculator. Minus 98, right? So we have to isolate the variables in order to solve the equation. So I need to get x by itself, so that means I need to do the opposite operation of addition, right? So 24 minus 98 is equal to, and if we remember correctly, this goes away, x is equal to -74. All right, now we have 1/3 being multiplied to x. Yes, we can divide by 1/3. And you can put that in, you can put that in your calculator just like that. Well, you would actually have to use the fraction button, or you would have to put this in parentheses, the 1/3. Okay, I think an easier way to go about doing that, 1/3 x equals 6, is multiplying by the reciprocal. What's the reciprocal of 1/3? 3/1. So that cancels out, and we multiply this by 3/1. So x is equal to 18. Okay, that's probably the best way to go instead of other, like dividing by the fraction. I just think there's more error to happen in your calculator. Okay, so here's some multi-step ones. So these are 2-steppers. The ones we just did were 1, right? So I need to go opposite of PEMDAS. I need to add or subtract away from the variable first, all right? So sometimes people like to highlight their variable. I need to get away from that x. So I need to subtract the 15 first. This goes away. And I have -5x is equal to -60. And again, I need to get this by itself. So I would divide by -5. So x is equal to 12. Not so bad. This next one here, it's kind of backwards, but it still works out. I need to get the x by itself. If it is easier for you to switch it around, if you prefer that, that's okay. It just takes up some more time. So here, I need to add or subtract away from the -4x. So it looks like I need to add a 56. Oh my goodness, my stylus is being strange right now. Okay, so -4x is still there. Cross that out. That's going to equal... Oh, I need to... What am I doing? You say, Miss Coates, you're off here. I need to be adding the 56 because it's a -56. So we got 12, 92. And then I divide by the -4. That's going to be 23. Right? -23 because it's a positive divided by a negative. All right. And that's it. And yes, you can leave your answer like that. I gave myself more room, it seems like, I guess because it was a one-stepper up there. All right. Now we have where we're going to have to distribute first. So that's the best thing to do, is to distribute first. Oh my goodness. Distribute the 3. So -10x plus 3 times 4x minus 2 is equal to 6. Why did I do that? Ladies, I am going crazy here on this weekend. 12x minus 6. There we go. Okay, so then I have -10 plus 12x. That's 2x. So these are like terms here, right? You got to combine those. And then I'm just going to drop everything else. So sorry, my phone. And I'm going to add the 6 on both sides. And I have 2x is equal to 12. And last step would be divide by 2. All right, next one. Go ahead and try it on your own. In a sense, we're going to distribute first. All right. When you distribute, remember that negative is going to change the signs of the things on the inside. Oops. These are like terms. These are like terms. And we combine those on the left-hand side. And then solve the two-stepper. And yes, it's nice to box in your answers when you're on tests and stuff like that. Tests or quizzes. Okay. I think I'm going to skip the last problem, but let's go ahead and do this one where sometimes you're going to have to solve the equation, then use that variable's value and plug it into an expression. This is a common thing on ACT. So I'm going to add the 12 here because I have to solve the equation first. And then divide by 6. So if x is equal to 5, and then I have to take that and plug it in there to know the value of that expression. Okay, and my final answer would be 35. We'll go ahead and do the other one in class on Monday. All right, have a good rest of your day.